So writing binary formulas. The first example there on your worksheet lists sodium and chlorine. And sodium and chlorine, they list the ion numbers of sodium, or the ion number of sodium and the ion number of chlorine. If you look at the periodic table, remember we went over in notes how to figure out the ion number. In group 1A, the ion number is +1. Group 1B, it's +2. +3 for 3A, plus or minus 4 for 4A, -3, -2, -1, and 0. Remember also that we explained this by using the valence electrons, the electrons in the outer energy level. We explained how groups 1A, 2A, 3A, and sometimes 4A can lose electrons. It's easier to lose a few than it is to gain a whole bunch. So they lose electrons, thereby becoming overall positive. By group 4A, 5A, 6A, and 7A, they're gaining electrons. Electrons are negative. So if you gain electrons, you're gaining negative charge and becoming negative. The noble gases are inert. That is, they don't react with anything, and so their ion numbers, of course, are 0. So knowing that, we can determine the ion number of any element. Although on the worksheet, I think it gives you the ion number for sodium as plus, and if it's just a plus, you know it's +1. Chlorine is negative. Okay, so writing binary formulas, what that means is you're actually combining these in a chemical reaction. If you have a positive and negative ion, they combine to form a compound. And the way it works is like this. The sodium and the chlorine are both reacting with each other, and since they're opposite, they can attract and form a chemical reaction and a chemical compound. The compound that they form is now together NaCl, whereas before it was written with a comma in between them. This is actually, you could put a plus sign on your sheets because you're adding those two together. It's NaCl, which is common table salt. These ones, since they are the same number, cancel out in the final formula here. Let's look at number 12. That was number 1. Let's look at number 12 as an example. Number 12 says iron, which is Fe plus 3, and what is being added onto it is oxygen, -2. Okay, now there's some rules. There's some rules, and here is the rule that you're going to need to know. You're going to cross over and drop down the ion numbers, and what that means is that you take this ion number, cross it over and drop it down to the iron as a subscript, and drop the charge. And you're going to take this 3, cross it over and drop it down as a subscript to the oxygen, so that these two are separate. This is some iron and this is oxygen. This is called rusting. So when it's done, you're going to form this stuff called FeO. It's a compound. It's made of 2 elements combined together, and it's called rust in common language. However, down here as a subscript, Fe has a 2. You drop the charge, and this O has Fe2O3. So it's Fe2O3. Remember the law of conservation of matter? Well, that's what we're talking about here. Because what you do is you add up the positive 3's that you need. I have plus 3, and I need 2 of them, times 2. That equals plus 6. Then I have oxygen. How many oxygens do I need? Well, there's negative 2 of them, so I need to multiply that by 3 to form negative 6. What this is saying is that the number of atoms on this side and the number of atoms on this side must at all times be equal. We'll get into the details of that in the next chapter, but I want you to know that when you cross it over and drop it down, you are conserving the number of atoms. So one rule is if the numbers are the same, you drop the numbers and it just reduces to lowest terms of 1 and 1, which you don't write. The other thing is you drop the charge and cross over the numbers. Okay? Does that make sense? Okay. Let's open it up to questions. Hold it.